Okay, there we go. That should show me, right? Infinite window, come on. Come on, infinite window. Let's go. Anyways, I was in a cafe. Wasn't gonna talk like a crazy person, but zip it. All right. Let's do this. Where was I? So we do need one more structure that's going to be called a free list, but I do want to quickly check if we can do something like put the tests in a separate folder. So let me. Let's see. Okay. Let me think about how to do this. So this isn't really scalable. I want to break this up into a separate folder. Also, you can place something at current. So, but if PQ current if it's equal to the capacity minus 1, that's fine. If it's equal to the capacity, PQ keep 0, return. We should probably return some kind of Boolean. Should return status, but whatever. This is just a little safeguard. It's not going to affect the tests. See? Okay. Let me see. Let me try a theory out. If I go into CD test and I do okay. You can do that. You can do that, right? I wonder if this works. Uncomment it. See what happens. And if we do make test, make test, make test. Wait. That just works like that? No linking including? Well, that was easy. How the fuck does that work? That was almost too easy. All right, well, bet. Let's just do this. Copy, just gonna snag that real quick, and then we'll do vi test pq.h, paste that in, and if not defined, test pqh, define, and then we just need to import a few things like these guys. Assert stdio, cdint, rand, and pq. Yeah, why not? And we just do this. So now this test file is super simple. Okay. All we gotta do, make test, Cool. We'll just say, actually, you know what? Don't need assertions. Don't need this. Don't even need that. Or this or that. Same thing. Ooh, does not like that. Okay. Why not? Okay, I think test ran.h. Or let me just get that real quick. Okay, this was a lot easier than I expected it to be. Go. Okay, test.main. Test PQ, we got a 20. Of course, you are expecting a U, but it is in fact this. That's okay. All right, cool. Let me just say git status git add source PQ dot c git commit guard for over capacity. Git add tests, git commit rearranged, reorganized tests. Git hold on. Looks good. Makefile is nothing important there. There's one more data structure we need to implement though. Let me show you. Let's do we need a free list of fixed size, and this thing is basically going to be for generating order IDs. Now we could just allocate with malloc and free, but that's not going to work because those are going to return pointers, and those pointers on a 64-bit system are going to be 64 bits, but we specifically need to fit them into 32 bits. So we're going to have to make our own, which is fine. What is this going to look like? Let me see PQ real quick. Okay. Let's just grab these real quick and include lfl.h. All right. So what is going to happen here? We're going to have an array that's initially going to be not initialized, and we're going to put values at some indexes. And then we're also going to need a separate array that tells us what indices are available. So indices 0, 1, 2, 3, 4, 5, 6, 7, 8 are all available. When we need to store something, we need to pop an ID. So we're gonna basically put something into that first one, and we're first gonna pop this. So this is gonna become that, and then at 0, we're gonna have something like this. Then we pop that 1, so we have something like this and that. And then maybe we're done with that 0 value, so we push it back onto the array, and we don't even need to clear it. It like we know that it's empty, so I'll just say garbage value now. Okay, so that's all we need to do. The fixed size makes it a bit easier, but let's do this thing. So let's see. Let's do the FL. I guess insert. It'll be called insert, and we'll call this will probably be we'll return a uint32 type, and this is going to be order ID is 32 bits, basically. FL insert is going to go, well, it's not going to be 32 bits, but we're going to store it as, oh god, this is complicated. I think it's actually going to be more like 25 bits. So it's like 32 bits. If you remember the priority queue we were building, it's 64 bits. 32 of those are going to be for priority. 25 are going to be for order ID in some cases. And then the remaining 7 are going to be for like what kind of order this is. This is all heavily debated in my notes, but let's see what it looks like. So we return a uint32. This is like the order ID. And this is basically going to be the index into that array. So, oh my god, what do we even insert here? Okay. This is going to be a little... we need a struct. We need that. We need a struct like this. We're just going to put it here for now. Type def struct, and this is going to be order. Order, we're going to try to make it as small as possible, but... and it really should not be defined here. It should be defined elsewhere, but I'm going to define it here now. Client ID and price type. This will change, but I'll write code in such a way that it doesn't need to order. Cool. So now we have an order type. Again, this is a placeholder and it'll come somewhere else, but order. Do we need to... is this a pointer or is this a real thing? Is this like the... are we going to pass in the value? I don't think so, right? Because order might be pretty big. We don't want to be passing those around, I believe. But, well, so let me just make this clear. This is going to be fixed size. We're also going to have a non-fixed size, but that's for later. That's going to be for the order book snapshot. Fixed sized free list. Okay. So if we insert an order, maybe it's it's a pointer. Wait, if it's a pointer, but then we put it into the, wait, if it's a fixed size, then we need to take the order and put it into the, wait, I'm so confused now. This is not going to be a pointer. I don't think so. But we do need we need another guy. We need type def struct fl, and this is going to be something. I don't know what, but it's going to be holding everything. This is going to be the first parameter, fl. This is definitely going to be a pointer. We do not want to pass in that whole guy. Okay, so we have the free list and we have an order. How do we put it into the free list? We're going to need to do something like to build, okay, we need to build a stack first, actually. Which is pretty easy. Stack, fl stack index. Wait. fl stack index. What are we doing with this? We get an index, right? We get an index. Um, I'm going to say UN32 type. I don't think we're going to have more than 4 billion orders in at any point. Oh god, this is weird. When does an order resolve? That's a good question. At some point. Okay, so we get an index. And then we do FL data at index is equal to order. Okay, and we also do FL stack index is equal to FL stack index minus 1. We decrement, which also means that if FL stack index is equal to, if it's equal to 0, what does that mean? Okay, here's what we're going to do. We're going to do something like return -1 or I don't know. 0 error, figure it out. We're actually going to do this first. So if it's 0, if it's at 1, that means we have one thing in the what am I saying? If the index is 1, that means that the last thing in the stack is like the last index available. And yes, we are going to be reusing order IDs, which might sound confusing, but oh well. FL, okay, which also means that we can do, I don't know, void maybe, FL release, and we just need to do FL, and we need to do some kind of order ID basically, and this is going to be U int 32 type order ID, and we just do, we push it onto the stack. So FL stack FL, okay, so if it's at 1, if the stack pointer is at 1, then if the stack index is at 1, that means we have one thing in the stack, and that thing is going to be at 0. So we can just place it directly at the stack index. This is going to be, we're going to push it onto the stack, not the data. So this is going to be order ID. We're back. Okay, but then we need to do FL stack index is equal to FL stack index plus 1. Okay, and I think that's it. Yeah, because we don't even need to like garbage collect the data. We can just overwrite it. So this is pretty simple. But we do need a void FL free, and this is going to be a bit more complicated. We'll actually get there once we figure out what the init looks like. But I think this is about it. All we need to do is return index. I wouldn't call it index, I would call it order ID technically. Okay, the stack index is more important. So data order ID, okay, that looks pretty good. Now, I don't know, void FL init, and this is gonna be, I don't even know. What do you want to do here? Can it be an empty, maybe? We're gonna do FL star FL is equal to malloc. I don't think we should pass in capacity here. But let's say, oh, I don't want to like wing it either. We should not be able to release if, I mean, the thing I'm worried about is, the only possible scenario is if order, or if FL stack index, if it's, if the stack index is at the maximum value, so if it's at capacity, return, because we can't, shouldn't happen, but prevents extra releases. Oh, it is raining out. Yeah, this one is much simpler than the other one if you can't tell, but until you get to the init part. Okay, so FL is going to be malloc. We just need 1 times size of FL. This one's pretty easy, but the data and the whatever are going to be more interesting. What we need to do is we need a pointer to we need an order. We're going to call this data, and that's going to be malloc. Again, I don't want to wing it. I don't want to wing this value. Oh, screw it. We can throw in capacity. UINT. Because the order ID is UN32, I'm going to have this as a capacity. Although really it's going to probably be passed in 2 to the power of 20. Malloc capacity times size of order. Is it order star or order? I'm going to guess it's this. I have no idea. We should stress test this. Okay, so that's data. This one doesn't have to be initialized to anything, but there's going to be another one. It's going to be UINT32 type. This is going to be indices. So basically the free list. We call it stack. It's going to be also capacity, but we're going to have a bunch of UINT32 types. Okay, and now what we need to do is go through, int I, I'm so lazy. UINT32 type. I is equal to 0, I is less than capacity, I believe, yeah, I plus plus, and we just fill in every one of those motherfuckers. We do stack, stack I is equal to I, pretty simple. And then we do FL data is equal to data, FL stack is equal to stack, and I think the rest of them are just going to be numbers. We'll do FL, I'll call it SP because stack pointer is equal to, it's going to be at the very top, so I think we just set it to capacity because we first decrement, yeah, so this is fine, capacity. And I think that's all we need, so we can just construct the struct itself, so we'll have UINT32 type stack pointer, yep, UINT32 type stack, or it's going to be that, and then we're going to have UINT32 type, this is going to be, oh no, order type, this is going to be data. And let's just put this guy above this guy, and I think that should be good. All right, so now just change stack index real quick to stack pointer. Okay, looks good. Oh, not yet. Okay. Free, that makes it pretty simple. You have free data, stack, and free itself. Okay, cool. We have release, void. Okay, I think this might be all we need. We can test it out actually. So, oh shit. Okay, I need to head out and like pretty soon. So we'll see how fast I can do this. eat some yogurt with a fork, because that's how we do it here. I don't care. Oh no. I froze this yogurt. Now it's too cold. Shit. Oh my god, I'm not gonna be able to eat this. Should have taken it out sooner, I guess. Actually, no, it's not bad. It's kind of like shaved ice, I guess. Except it's shaved milk. Shaved frozen milk. Okay. Where are we now? Okay. Now what we do, cat source FL. Let's go ahead and take all this, put into the header file, paste, and now what we're gonna do here. Order doesn't matter right now. We'll come back to that. Obviously not gonna include itself, but we are gonna need something like this. Even capacity, I don't think that should be. It's gonna be dynamic, so it'll resize. So it doesn't even matter, to be honest. I don't think. FL release. This is like release order ID technically. Okay, so now we can get rid of this. Oh no, we need that. We need that. Okay, FL SD lib. I don't think we need. What is STD lib for? This is for malloc. We don't need that there. Okay, cool. We can write a test for this now. So let's go into vi test. We'll call it test fl.h. And how do we do a test again? Vi test test pq.h. Okay, someone's already opened it. There it is. I see it. Okay. We'll do if not defined test flh define test flh and if. Cool. Void test fl. And we can do whatever we want in here. We'll do fl is equal to fl init 1024. Why not? And then we'll do fl. Rand is not going to help us here. I don't think so. Oh. Wait. Probably one of the most important things. Is it important? I don't fucking know. Maybe. Whatever. Smoke test. Let's see if this works. If this doesn't work, we got a serious problem. Okay, someone else also has this open. All right. Okay, let's see how that works. I actually don't need to do anything here anymore. Make test fail. Yes. Okay. By type void, yes, you should not be a void. You should be a FL type. Oh, and you need to return. And return FL. There you go. Did you not hear me? Oh, wait. How is this even working if I didn't include it in the make file? There we go. FL. Try again. Okay, that's a different error. What else you got for me? Conflicting types for FL int. Right, because we didn't update the header file. You are now a FL star. Go. Oops. Silly me. 33. Oops. And the other one is 43. No capacity. Right. Yeah, we should definitely have that. Where's the... do we need that though? Do we need that though? Yes. Yes, we do. UINT. This has to be the same type as stack pointer, so capacity. And this one's gonna be pretty simple. Capacity. We definitely need that. Go. It's right there. What are you talking about? Oh no. Oh, I know. I know. This is definitely not getting. This is definitely becoming unscalable, but. And here, I'm not sure how to do it. Okay. That didn't crash, which is good, which is actually huge. Usually you'd see a seg fault here. Okay. Watch this. Now we need to make an order. Okay. Order is equal to. There's like a cool way to do it nowadays. I think this is like pretty new. No, what's the other way? What's the other way? Come on. There it is. Okay. Struct my... like that. We just need to make sure we get the order right. So that's going to be... Oh, it's just 4 and 32s. Okay, we can do 1, 2, 3, 4. All... Actually... no, all of these are going to be ints, including price, because price is going to be... Oh, price might be an int 16 by the time we're done with this. So only allowing us to go up to 655 bucks. Okay. Let's see if this crashes, by the way. Okay. Int 32 type order ID is equal to... We're just going to put in the same order a bunch of times and see what happens. FL insert. Is it? Do we want to say insert or what? Yeah, we do. Order. FL. Let's see if this works. Okay. I'm going to do. This is a void. FL release. FL order ID. Let's see what this does, by the way. Okay, cool. Now, while we do that, I also need to make sure that FL data order ID, which this could be a getter. Should this be a getter? Maybe. Maybe. Let me just we can do an assert. Assert saved order dot what is it? Quantity. Make sure these match. Damn it. Okay, whatever. Assert saved order dot quantity is equal to 1, and the rest of them. I'm going to do client ID, price, and type, and we're going to do 2, 3, 4. Okay, talk to me. Oh my god, it all didn't crash, so that's probably good. 5. Okay, that's not good. Let's get a print statement out. Testing FL. Okay, that just tells me that we weren't actually running anything. Okay, So how can it be 5 and 4 at the same time? Oh my god. Duh. There. Ooh, okay. What's the, okay, so it is 4. Good. Good. What are you doing? Time check. Okay, 3 minutes. Testing FL does not crash. If we save the same order, what happens? I have no idea, actually. I'm actually really not sure about, like, does this get copied? Because I think I need it to be copied. I'm very confused. Well, it seems to be working. Oh, let me try this. Order dot. Make sure it doesn't change. It should be copied, not 4. If this fails, okay, cool. So it is copied. Cool, that's nice. Order that type is equal to 5. We could do this same thing. Order ID. Now we actually need to keep track of these order IDs. Let me just do a targeted fix. So we'll do FL data order ID 2 dot assert data dot type is equal to 5. And if this works, then they are definitely copied. They are copied. Cool. Just what I needed. Although it might not be even worth making the order type in the first place. I might just send the quantity, price, and type directly to the free list. But this is pretty good. This is pretty good. We made progress on, in just a few minutes, we made massive progress on free lists. The next one is going to be a fixed, we need to do this probably. Actually, you know what? If we release both and we overwrite it, it should be, this will pop 1 back onto the stack. That'll pop 0 back onto the stack. So then if we do this again, this should still be 3, I believe. This should still be 0, I believe, which we can actually add an assertion on. Yeah, assert order ID 3 equal to 0. There's no magic, so this should be fine. Then we can do assert this guy, order type 3 is equal to 4 or 5, because we 3, 2, 1. Oh, not so fast. Okay, what's up? Oh wait, no, it's gonna be 1024, isn't it? Because we take from the back. Yeah, okay, so it's gonna be 1024. Right? Or 1023? No, it's gonna be 1023 because we have to go down first. Bingo. Cool. Alright, yeah, that looks pretty good. I'm actually gonna save this. Git add, include source, git status, git commit. We'll call this fixed sized free list implemented. And we're gonna do git add, what is it? I don't like the phony. I'm not a phony guy. Okay. Test for free list. Git push. All right. Okay, cool. Next up is going to be, we're actually almost done. We're ready to come up with the more interesting structures, but these are like the underlying data structures that we need before we can do anything else. We'll also need a, so that's for the order types. The orders are always going to be the same size. They're always going to create the same thing, but I think, but the, what do you call them? The order book. The order book is going to be variable size, and that's why we also need a variable length free list that is going to basically now this one we could do with malloc and free, so we basically leave the like memory handling to the OS, and we just, okay, the order book is now going to be this big, let's malloc that much space whenever the last snapshot, because in this simulation we're going to have snapshots of the order book, because basically at some point in time there's going to be like a certain order book, and then sometime later that order book is going to, you know, go through the network and it's going to arrive at the at some client, but then at the same time the order book might change. So at a certain time the order book server and some client will see different snapshots of the actual order book. So for that reason, and they're going to be different sizes, and we need to keep both. We need to keep a reference to both. Now that might just be a an address in memory. So uint60. So it'll be a 64-bit address, which might be fine. I'm not sure, but those. How did I do this? Well, anyways, that's one way we can do it. The other way is to basically do it manually, so not leave it to the OS, but just allocate a big chunk of memory for a bunch of snapshots and then kind of manually manage it. And this one will kind of look like a free list, except you take the free list, you split it up into, the free list will start as like one big block, and then you insert something that'll turn into a smaller block with a certain offset. Yeah, it's complicated, and I don't have time to go into it now, so see ya.